Hello guys, welcome back to Rosario's Way. This is Rosario Borgesi and today I want to discuss with you an important example of ERC20 token deployed on the Ethereum blockchain, which is the Tether USDT token. So let's get started. So let's start by taking a look at this website, which is CoinMarketCap, that lists all the cryptocurrencies along with their prices and their market cap. Um, as we can see, there is Bitcoin, Ethereum, Tether, USDT, Solana, BNB, etc. What is Tether USDT important for? Tether USDT, it is a stable coin, which means that its value it is stable. In this case, this is a token, Tether USDT, that is pegged to the US dollar, and its value should be always equal to $1. And if we take a closer look to its history, we can see that apart from some rare moments where it has um, had some changes from its desired value. It is always more or less stable to the value of $1. So this is what the Tether token has been created for. If we go to the Tether website and especially we check this page, this lists all the types of Tether token, because we have seen the USDT token, which is the token created by the Tether company that is pegged to the dollar, but there are also other tokens that always created by Tether that are pegged to other fiat currencies like euros, and so on and so forth. You can see all the possible tokens listed here. What is also important to see from this page is that the Tether token has been developed for various blockchain. You can see it has been developed on Tron, Ethereum, Solana, Omni, Avalanche, etc. So this is really important, and as you can see, the description that Tether gives us is that all Tether tokens are pegged one-to-one to a match in the fiat currency and are backed 100% by Tether reserves. What does it means? If we go to the to check the reports of the reserve, we can see that the 85% of the reserves of the Tether company are constituted by cash and cash equivalents. So uh, really this token, it has been created to be pegged um, to the fiat currencies. But now let's go to an article that I have created for this video, and we try to understand deeper in detail um, the uh, the um, the code of the Tether token that has been deployed on Ethereum, especially the USDT token. So we are focusing on Ethereum and on the USDT token, so the token that is pegged to the dollar. It is important to understand that a token is different to from sorry a cryptocurrency, because um, a cryptocurrency like Bitcoin or Ethers in the case of Ethereum, because Ethers is the native currency of the blockchain, while Tether it is a token. What does it mean? It is a token. It has been developed a standard to create the token, which is called the ERC20 token standard, and the, it is this is an article that I have created that also introduced you to the ERC20 token. What is the ERC20 token standard? Basically, it defines um, a set of function and of events that the token must implement. So this is an interface which defines this function. If we want to create an ERC20 token, we must implement all these function. Um, like in Java, when for example we have an interface and we implement an interface, we must implement all its method. Also here in Solidity, if we define this method in an interface in a contract that acts as an interface, we must create a contract that implements all this method. So this is basically it defines what method and what um, events an ERC20 token must have. As you can see, there are a lot of functions like name, which returns the name of the token, symbol returns the symbol, decimal. This is important to get the decimal of the token, the total supply, the balance of a specific account, a method to transfer an amount of money to another address, the transfer from that transfer an amount of tokens from one address to another, and then the other two methods that are approve and allowance. So this is the interface that we must implement. We must bear this in mind to understand why the Tether token is an ERC20 token. So if we now go to Etherscan, this is here we can see the code that has been deployed by the Tether company to the Ethereum blockchain. We can also see the code, because the code is public, and as we can see, this is a token. This is a code quite old, because it is a version of Solidity 0.4.17, so it is really old, and it has been deployed, if I remember correctly, in the 2014. So it is really old. Here, let's get back to the article we were talking about. Here I have reported the code, and now we will discuss it by deepening in all its components. So the logic of the contract, the whole code is composed of this library, which is the safe math library. It is a library that nowadays it is not it is included in the contract, but it is basically a library that allows the developer to perform safer operations, safer mathematical operation like multiplication, division, subtraction, and addition. Basically, it is this is its role. Then they created an own ball contract, which is a pattern that is still used. and it basically it is used to define the owner of the contract, which at the time of the deployment corresponds to the contract that to the address that is deploying the contract, which is message.sender. And so the owner is set this way. Of course, this is it has been defined the modifier only owner to allow only the owner to perform some action. This is important for security reason because we don't want, for example, some function to be called by other addresses. The transfer ownership that allows to transfer the ownership of the contract from the actual owner to a new owner. This is very simple but very important contract that it is used also now, today. Then we get to the where are defined the where there is um, the interface of the ERC20 token. As we can see, here are defined methods total supply, balance of transfer, the event transfer, which are has been divided in these two contracts, ERC20 basic and ERC20 which is inheriting from this contract. So this should be the full the full interface, which has also the methods allowance, transfer from, and approve that, as we have said before, constitute this interface of the ERC20 token. So now the basic token is a token that inherits from the ownable, so it allows us to set the owner at the deployment of the contract. It makes use of the safe math library that we have defined before, and it basically implements some function, for example, the transfer function and the balance of function. As we can see, it also makes use of the balances are defined with an hash map, which is this mapping here, which is important in order to retrieve with an O1 complexity algorithm. Then it defines this modifier to address the ERC20 short address attack. And here there is this implementation that I would not go into the details because it might have some operations that are related to the Tether wire transfer token, but basically it transfer the tokens from one address to another. So nowadays we have this implementation. We can get this implementation right away. We don't need to implement ourselves. In fact, if you go to this Medium article where I explained various type of implementation of the ERC20 token, we can see that just by inheriting from the ERC20 of the Open Zeppelin library, we get this implementation of the transfer function right away. We don't need to develop it, and this also applies to the all other function that are listed in the ERC20 token. These are all have been implemented in the ERC20 contract, so we don't need to develop ourselves. So it is already been done for us, and it's been made in a safer way by Open Zeppelin, which is really a standard library to use when developing with Ethereum. So then it is being created the standard token, which inherits from the basic token that we have discussed here. Other functions have been developed, like the transfer from function, the approve function, the allowance function. Okay, will not enter into the detail because, as we said, these are basic function. For example, transfer from is used to transfer from one address to another a certain amount of tokens, so it is very simple. But and as we said before, maybe there is a logic specific to the Tether token, but basically it is used to transfer the tokens. Then we can give a look at the possible contract. This is an important contract which allows to it is an emergency mechanism to stop the contract if we, for example, realize that there is a bug in the code and we don't want to the code to work for a period of time, for example, or we want to make some checks in the code and we want to stop its functioning for whatever reason. So this is basically as two function to pause and to stop and to reactivate the contract. This is basically it, and to modify to make sure that the contract is not paused or it is paused. That is it. Not really that. It is not that complicated. This is another very important contract, which is the blacklist contract that allows to create a blacklist of addresses. Also here it has been developed, it has been implemented as a mapping, so as an hash map. Here basically you can add or remove an address to a blacklist, and you can remove the funds from that address if you want to. This is the role of this of this on this contract. As you can see here, maybe I have not discussed it before, only the owner of the contract can perform this operation, because here we have the only it has been called the only owner modifier. Then this is an interface upgraded standard token that is used to upgrade the Tether token in the future. If you want to deepen your knowledge on the upgradable contract, I have written this article on Medium. You can check it in the description. It will enter into the detail, and even though it is a newer way to create upgradable contracts, it still will be helpful to understand better how this pattern of upgradable contract works, because as we know, the blockchain is immutable. So when we deploy a contract, we cannot change it later. Basically, this is the idea. But as we know um, computer engineering, when we develop something code, for whatever reason in the future we may need to change it to correct to fix some bugs, or to add new features, or to change some functions. So this is a pattern that allows to change the code, even though the code itself, once deployed on the blockchain, it is immutable. Let's imagine that we are the user and we initially only deploy the Tether token. So we, for example, call the function, for example, the transfer function. Let's add a text here. For example, we call the transfer function, and we call directly the Tether token function that we have deployed. This upgraded standard token, if we, for example, decide to deploy a newer version of the transfer function, we will not call directly the transfer function on the Tether token, but instead we will call the transfer by legacy function of this token here. This is maybe not good, because this should be here. Okay, so we are not, if we deploy a newer version of the Tether token, which is the upgraded and standard token, we are not, if we call the transfer function from the user, we are not calling this one, but we in reality we will call the transfer by legacy function that we see here. And this can be seen here, because what happens here, as we see, the transfer function of the Tether token, if the contract is not deprecated, will call its own the transfer function of the standard token that we have discussed before. Otherwise, if the contract is deprecated, we will call the transfer by legacy function of the new upgraded standard token that we have deployed at this address. What is this address? This address is created here with the deprecate function. When we call the deprecate function, we are saying that this implementation, the old implementation of the Tether token, is no longer valid for us. So deprecated gets is set to true, and we are setting this upgraded address variable that when the contract, as we said before, gets deprecated, is called the newer function, which is transfer by legacy, which contains the new logic of the transfer function. If it is not deprecated, it will call the old function. Please bear in mind that with this means that we are calling the upgraded standard token contract at the address that is contained in the upgraded address variable, and from this contract we are calling the transfer by legacy. So this is the new implementation and this is the old implementation. This is also valid for other. So this is the interface of the contract. Our new contract must implement all this function. This reasoning can be applied to the transfer function, the transfer from function, and the balance of function, while and the approve function. While here, for example, if we want a newer version of the allowance function, we must deploy a new standard token contract at a new address, and we must call it's the new allowance function. So there is this difference. If we want to create a new allowance function, we must create a new standard token contract. If we want to create a new, for example, transfer function, we must create a new upgraded standard token. So this is an older way of creating an upgradable contract. If you take a look at the article I've mentioned before, you can see that now it is it has been improved. This mechanism, it has been improved. So the most important thing is the deprecate function that allow us to deprecate the actual contract and to call a new version, a new contract that has the new implementation that of the function that we want to substitute. Now, there are two other important functions, which are the issue function and the redeem function. The issue function, it is created to mint new token. Please bear in mind that for the tokens we use the word mint, which means basically to create new token, which is different from mining, which is the which happens when we create new new currencies like Ether, in the case of the Ethereum, or Bitcoin, or new Bitcoin in the case of the Bitcoin um, blockchain. So this is used to create new token. As you can see, there is not a cap supply, so we create an infinite number of token. And this is the redeem function, which is created to burn token. And in the newer implementation from OpenZeppelin, as you can see from the article that I have suggested to you, there is it is given us right away the implementation of the burn. The function to burn a token is called burn. It is given right away. We just need to extend this contract. So that is the difference. And this is why this has been implemented. Let's take a look at the Tether perspective. Tether, it is a service that when the more users who buy more token, they basically issue more tokens, and they should buy new dollars to store in their reserve. So when new users buy new USDT token, they issue more token and they transfer it to the user that has bought them. While if the user redeems the token, so it gives back the token and gets back the money, the token get burned. And now we should take a look at how this proxy contract works in reality. No. This is another important point I forgot from the Etherscan, we can see what parameters were passed to the Tether token constructor. The constructor is this one. The Tether token blacklist content Tether token. This is the constructor. So basically here we are defining the initial supply, which goes all to the owner, as we can see here, the decimal, the symbol, the name, and we can see here what parameters were passed at the time of deployment. There were 6 decimals, so it means that were 4 6 zeros. If we eliminate the 6 zeros, we can see that were deployed 100,000 tokens, because this account for the decimal part, and the name was Tether USDT and the symbol was USDT. So we can also check the parameters here. And now I would like to see more in action this upgradable pattern. So I have discussed in this article what I've done to test it. Basically, I've deployed the Tether token that we have discussed with the code that we have taken from Etherscan at this address. Then I deployed a new version, a new contract, upgraded standard token that has all the code of the Tether token, while I have eliminated the as expressed here. I've eliminated the Tether token contract. I have implemented all the functions that were only defined in the interface, that were transfer by legacy, transfer from by legacy, and approve by legacy. As you can see here, there is the full code of the new contract. So this contract, basically what it does, it emits an event here when we call this function, 3 different events that have been defined here. This to make sure that when we call the transfer function on the Tether token, that we have here, so what is the point here? When I call the deprecate function to deprecate the old Tether token contract, it should call the new transfer by legacy function, so it should emit an event transfer by legacy and not calling this transfer, the old transfer function, which moved which transferred the tokens to another account. So I want that this event, the transfer by legacy event that I've defined in the new contract here gets called, and in effect I deployed the new contract. Upgraded the standard token. I called the deprecate function, and I called the transfer function with arguments. This should be the receiver, and this is the amount of token. As we said before, no amount of token should be transferred because we are just emitting an event. And so if we examine the transaction receipt, it gives us here in the logs the event that were called, which is transfer by legacy. So the proxy pattern worked fine, and it has been called the new method, transfer by legacy, of the new contract upgraded standard token. So we have reached the end of the video. I hope you have enjoyed it. If you have any questions, please drop a comment below and I will answer you as soon as I can. And thank you for watching, and see you in the next video.